If a particular user has logged into our website to read a particular blog post, then how can we suggest the related blog post to him using the techniques like machine learning and natural language processing is what we are trying to understand as part of this video series. All the links related to this particular video series I have given in the description box. In this particular video, we will see how can we measure the similarity between two blog posts using the techniques like count vectors. Hi, this is Aditya. I do videos on latest technology trends and their technical implementations in the field of digital marketing. If you are interested, please subscribe to my channel. Let's get started with the presentation. These are the three sample blog posts which we have taken as an example in our previous lectures, and we are trying to implement all our models and all our analysis on these three blogs. And in this video, what we are going to see is if the user is reading blog 1 on the website, then which of these two blogs are most related to this blog 1 and which one can we suggest as the related blog to him is what we are going to see in this particular video. So for that, what we have already seen is we will need to take this blog post, and as a next step we need to do the text cleansing. Okay, so as part of the text cleansing, we already saw that we will remove all the unrelated words like are and good, and we will keep only those words which are actually related to the topic. Okay, so blog 1, blog 2, blog 3, all these blogs we have cleansed, and the cleansed text we have seen is this one. Okay, and then as a next step, what we'll do is we will do the vocabulary creation. Okay, so as this step, what we have done is we have seen all the unique words which we have used in these cleansed words, right? So all these cleansed words we have taken from each blog, and we have identified what are the unique words which are used, and then this will be the list of all the unique words which are used across all the three blogs which we have taken into consideration. So till this step we have seen in our previous lectures. So our thought earlier was to imagine each of these words as one of the dimension in the coordinate space, and then map each one of our blog posts in this 11 dimensional coordinate space. That is what we have discussed in our previous lectures. Okay, so now we will see the process of doing it. This process of doing it, what we call it as count vectors. Okay, so this is how we do it. Let us suppose we take this as blog 1, right? So each of this unique word, we will see how many times it has repeated in this blog 1. Let us suppose we have taken the word Rama. Then we will see how many times Rama has repeated in the blog 1. So it has come once. So then we will put a number 1. So it is just that we are counting how many times a particular word has repeated itself in a particular blog. In this case, we are taking blog 1, right? So I have taken Rama, then Rama has repeated once, so I have put as number 1. Then Krishna has also repeated once, I have put number 1. Then I will see the friends, if it how many times if it has repeated, then I will say friends has repeated once. So if, for example, if the friends has repeated twice, then I will put the number as 2. So how many times it has repeated, I am just counting. So similarly, all other words, if it hasn't occurred at least once, then I will put it as 0. So now what I have got is, I have got the mathematical representation of the blog 1 in the 11 dimensional space. So if you imagine all these ones and zeros to be the coordinate point, right, in the 11 dimensional space, then we have got the mathematical representation of the blog 1. So similar analysis I would do on the blog post 2 also. So each of this word, how many times it has repeated in blog 2, that also I'll see, and I'll count each of the repetition of each of these word, and I'll mark the number here. So this is the points I'll get. So these are the numbers I'll get. And we can again imagine this entire thing as a point in this 11 dimensional coordinate space. So we have got the mathematical representation for blog 1 and blog 2. Similarly, we'll do it for blog 3 also. Each of this word, how many times it has repeated. So that I'll mark it here. So now we have successfully converted each of these blogs into the mathematical representation. So now let's try to understand some mathematical concepts and then try to compute the similarity between these blog posts which we have represented mathematically. So the concept which you need to understand is vector. So let us suppose we have this two-dimensional coordinate space. If we mark a point here, then this is called as a point in this coordinate space. But if we can imagine a line which is going from origin towards that particular point, then this line with this arrowed line, this is called as a vector. Any mathematical representation, be it either vectors or matrices, the purpose of them is to simplify the process of computation. Let us also remind ourselves as to what we have discussed in our previous lectures as to what is vectors in terms of programming language. Okay, so if this block 1 is an array, right, if this is a variable which holds an array of these values like 1 1 1 0 0, if this entire thing is an array which is assigned to this variable block 1, then block 1 is called as a vector. This is in terms of programming language. Okay, we have already seen what is the mathematical imagination of a vector. Now I am talking about the programmatical representation. So having said all this, let's see how do we arrive upon the measure of similarity. Okay, so all this we have done to ultimately figure out which two blog posts are most similar, right? So how do we measure that? That's what we are going to understand now. So again, these are the representations, right? So blog 1 is represented, let us suppose, as an array of these integers, okay, which in programming terms is called as a vector, right? Now block 2 is also a vector because it is an array of integers, and block 3 is also a vector. Now let's come here and see what is the mathematical representation of it. So though these are the vectors which are there in the 11-dimensional space, we are just putting it into 2-dimensional space for our convenience purpose and imagination purpose. Okay, so let us suppose this is a 2-dimensional coordinate space, and this is block 1, this is block 2, and this is block 3. Then a line going from origin to this point is called as B1 vector, and then line going to from origin to this block post is called as B2 vector, and then line going to origin from this block 3 is called as B3 vector. Okay, so B1, B2, B3, these are the three vectors. Okay, so now let us suppose now the user is reading block 1. Okay, so how do we find which is the other block which is most related to this block 1? So in order to find that, what we need to do is we need to subtract this array or this vector with this vector. So what we will do, we will just each of this element, like we have the first element as 1 here, we will subtract this first element of 1 with this first element of 1, and the result we will put it here, and then we will subtract this with this, and result we will put it here, and this with this, and we will put the result here. So like this we will subtract each element of the block 1 with block 2, and then write the resultant here. Now let's see the mathematical representation of it, right? So if you subtract this block 1 vector with block 2 vector, then the resultant of that would be also a vector which will be passing, which will be a line which is passing from block 1 to block 2, like the brown color line which you see here, which is passing from block 1 to block 2. So this is the resultant vector which you get after you subtract block 1 to block 2. Okay, so why we are doing this we will see later on. Okay, but this is the concept. Okay, this is the computation which we are simplifying just by subtracting each element of this with this. We are getting a resultant vector which is passing from this point to this point. So that is the mathematical computation simplification which you have brought through. Okay, similarly, if you subtract block 1 with block 3, then you will get a resultant vector which is passing from this point to this point. Now what we need to understand is each vector will have something called as a magnitude. So how do you calculate magnitude is you just have to square each of these elements, like 0 square, again 0 square, plus 1 square. So you will have to square each and every of these elements in the array, and you will need to just add all these elements as I am doing it here. So this gives the length of this vector. So now the vector is passing from this point to this point, right? But what is the length of this vector? That length is called as magnitude. Okay, so to compute that one, what you need to do is you just have to square each and every element of this array, add them and do a square root of it. Then what you get is this length. So ultimately what we are trying to find out here, we are just trying to find out what is the distance between this point to this point. That is what we are trying to do. And what is the distance between this point to this point. And to simplify that calculation of distance computing, what we are doing is, since we are using arrays, so we are just subtracting one array with another array. Just subtraction is very easy, right? So we can just subtract one array element with another array element, and that also mathematically we are able to imagine, like what is this? We have subtracted this with this vector with this vector, but what is the resultant vector which we have got? That we have imagined. Now we are just calculating the magnitude of it, which ultimately will give what is the distance between these 2 points. Okay, so what this entire vector calculation is doing is it's just simplifying the process of computation of what is the distance between 2 points in this case. So ultimately we have got the distances. So let us suppose the distance d12, which is square root of 4. Okay, what is this distance 12? The distance between block 1 and block 2 is square root of 4, and distance between block 1 and block 3 is square root of 8, which is obviously like this distance 12 is lesser, which means that block 1 and block 2 are mostly related than block 1 and block 3. That is what our algorithm is predicting now. After all this computation, this is the algorithm. So after all this computation, the output of that algorithm is, it says block 1 and block 2 are most related. Okay, so let's try to validate if that is true. So this is the block 1, right? Rama and Krishna are good friends. Then this is the block 2. Rama went to Krishna's house. His house was very beautiful. So our algorithm prediction that block 1 and block 2 are related seems meaningful, because the main topic which we are discussing here, Rama and Krishna, right? These 2 blocks seems to be like a continuation. We are just first saying Rama and Krishna are good friends, and then we are saying Rama went to Krishna's house and his house was very beautiful, as if it is a continuation to this line, right? But if you compare block 1 to block 3, here the main topic is Rama and Krishna, but here the main topic is dog and horse, right? So here there is no Rama and Krishna itself, though the house is there, right? But the house is not there here. And friends is there, but the friendship is between dog and horse and not Rama and Krishna. So it makes sense that our algorithm says that block 1 and block 2 are related, and block 1 and block 3 are related also based on the friendship, but then not as related as these 2 are. So this is how we will compute the similarity between 2 block posts using count vectors. If you have any questions, please post it in the comments so that I can answer them. Thank you.